For my final reflection, I've decided to do a little mini lesson on the rules for finding derivatives, focusing on the power rule and the product rule. So we'll start with the power rule. So, as we know, when we have a function, let's say x to the n, we know that the derivative of that function, let's hold on one second. So we know that the derivative of that function is going to bring the n, I really suck at drawing with this, by the way, you guys will have to bear with me. So the derivative of that brings the n down as a coefficient in front of the x. So n in front of x, and the exponent subtracts 1 from your original exponent number. So this is the basic setup for the power rule when it comes to finding the derivatives of functions. So knowing this, let's take a look at a couple of examples, and we'll start with a bit of an easier one over here. If we've got f of x equals, whoops, okay, f of x equals x to the 7th power. So looking at our rule, the derivative is going to bring the 7 down to be a coefficient in front of the x, and you subtract 1 from the original exponent. 7 minus 1 is going to give us 6. So we bring the 7 down. Whoops. Sorry, bear with me. I suck at this. So the 7 gets brought down as a coefficient, so it becomes 7x, and then to the 6th power, because you're subtracting 1 from the original exponent. So that's a pretty simple one for the power rule. So let's try another example now, one that's maybe a little bit more complicated. This is good experience for me. I have such limited experience working with smartboard programs, so I'm learning on the job here, so bear with me. Sorry. So let's try a little bit more complicated one. How about one that has a fraction in it? So f of x equals x to the 4/3 power. So a terrible 3 there. So we're doing the same thing, bringing the exponent down to be a coefficient. So our derivative function using the power rule would be now 4/3 x, and then remember we subtract 1. We subtract our original exponent by 1. So 4/3 minus 1 is going to give us 1/3. So that's our derivative function. We bring the 4/3 down into the coefficient and subtract it by 1, and that gives us 4/3 x to the 1/3 power. And let's try one more. Let's see. Okay, so let's try a function in fraction form. as a final example that's maybe still a little more difficult. So we've got our function being equal to, let's say, 1 over x squared. So the first thing we have to do here is take it out of fraction form. Take our function out of fraction form in order to be able to use the power rule correctly. So our derivative is going to start by flipping this. So 1 over x squared becomes x to the negative second power. So now we're ready to use our original rule for the power rule. So we bring the negative 2, that's our exponent, down to be the coefficient. Whoops, yet again struggling. So we bring the negative 2 down to be our coefficient in front of our x. And remember, we subtract our exponent by 1, which in this case is going to be negative 2 minus 1, which is negative 3. So now we have negative 2 x to the negative third power, which would be fine, but we can't have the exponent being negative. So we have to do the opposite of what we did over here at the front of the equation when we were getting it out of fraction form. So we're going to turn it back into a fraction. So we kind of split this like this for a moment. Forget about the negative 2, and we take the x to the negative third. And turn that back into a fraction. So that's going to be 1 over, so x to the negative third becomes 1 over x to the third. And then we apply the negative 2 to the numerator. So our final answer for our derivative of the function is negative 2 over x to the third. There we go. Okay, so that's about it for power rule. So I want to do one quick example for product rule. So the basic rule for the product rule is to multiply the derivative of the first function times the second function plus the derivative of the second function times the first function. So obviously you need to have two functions in one example in order to be able to use the product rule. So let's take an example, just do one example here that will illustrate the product rule for us. So we're going to have our first function will be x to the third plus 7x minus 1. And our second function will be 5x plus 2. So now we've got our two functions. So first step in finding the derivative is we are going to take the derivative of the first function. So the derivative of the first function is 3x squared, because we're now kind of using the power rule within the product rule. So we see that x to the third, we bring the 3 down to the coefficient, and that leaves us with 2 as our exponent. So we're using the power rule on that function. So that becomes 3x squared. 7x becomes just 7. We lose the x, and we're left with 7. And as we know, the derivative of a constant number is always 0. So for -1, we're left with just 0, so we don't have to write that in. And then, so that's the derivative of our first function times our second function. So we just have to rewrite that, 5x plus 2. And then we are going to add that to the derivative of the second function. So the derivative of the second function is just 5. Because 5x, the derivative of that is 5, and the derivative of 2, again, it's a constant, so the derivative there is 0. So the derivative of the second function is just 5. And our first, and we're going to multiply that by our first function. So we're just rewriting that there. So that's the beginning of our derivative. So now we need to do a little multiplying here in order to simplify this a little bit. So we're going to start by foiling the first part of this derivative. So we have 3x squared times 5x, which gives us 15x cubed. So 3x squared times 2 is 6x squared. 7 times 5x is 35x. And 7 times 2 is 14. And then we're multiplying the second part of the equation. So 5 times x cubed is 5x cubed. 5 times 7x is 35x. And 5 times negative 1 is negative 5. So now all we have to do is combine our like terms. So we've got a 15x cubed and a 5x cubed. We've got a 35x squared and a 35x squared. And we've got a 14 and a negative 5. So when we rewrite the simplified version of our final derivative, we've got 20x cubed, because we are combining the two x cubes. We've got 6x squared. We've got plus 70x, combining the two 35x's. And we've got plus 9, combining the 14 and the negative 5. And that's, so there is, yeesh. Man, I really suck at this. Anyway, so that is our simplified derivative function of our original two functions. So that's the deal with product rule, and that's the little mini lesson on the basic concept of power rule and product rule, how they relate to each other, how they can be used within the same functions. And that's about it. So thanks for bearing along with me as I struggle through this smartboard. That's about it. Thank you.